today's video, I'm going to be solving this geometry problem that I have right here. So there's this square, and we're asked to find the area of the shaded region. And the only information that we have to start is that these two bases of these two triangles are the same length, and these two line segments are the same length. And this line segment makes a 90-degree angle with this line segment, and that this side of the shaded region is equal to 1. It's the only information. Oh, and that the whole thing is a square. Square. The only information that we're given, and we're asked to find the area of the shaded region. So the way to go about doing this is I'm going to assign a length to each of these line segments. They're equal, so I'm going to call each one x. So that means this total side length of the square is 2x. Since it's a square, this is also equal to 2x. Up here, 2x. And then this segment is equal to 2x minus 1, of course, making the total side length 2x minus 1 plus 1 equals 2x. So the area of the whole square is equal to 2x squared equals 4x squared. And the area of the shaded region is going to be the area of the whole square minus the area of each of these three triangles. I'm going to label the hypotenuse of this triangle as 3. So this is 1, 1, 2, 2, 3. And I'm going to call this one 4, the side of this triangle. And the area of the shaded region, again, is the area of the whole square minus the area of this triangle, this one, and this one. Let me call this one A, this one B, and this one C. So area of shaded region is equal to a square minus AA minus AB minus AC. So that's the ultimate goal, is to get the area of the shaded region. The area of a triangle is equal to 1/2 base times height. Of course, we learned that in geometry. So let's do the area of A is equal to 1/2. The length of the base is x, and the height is 2x minus 1. So the area of A is equal to x squared minus x over 2. Okay, that's the area of this triangle. The area of B, actually let's do the area of C first. The area of C is 1/2 times base x times height 2x. So it is x squared. Area of C is equal to x squared. Let's plug them into the total area. Is equal to 4x squared minus x squared plus x over 2, because this minus sign distributes to each term, minus x squared minus area of B. So there are only two things we need to do now. It's to find the area of this triangle B and to figure out what x is. How are we going to find out what B is? So these are right angles, of course. Can find out the base of B. The base of B is this 2. It's equal to 1/2 the hypotenuse of triangle C. So remember Pythagoras' theorem. The hypotenuse of C, let's call it HC squared, is equal to a squared plus b squared, where a is x squared and b squared is 2x squared. So it's x squared plus 4x squared equals 5x squared. The hypotenuse of b is the square root of that. It's root 5x. That's the hypotenuse of b. And remember the hypotenuse of c. This is, the hypotenuse of c. We want the base of b. The base of b is, this is 2, is equal to hypotenuse of c divided by 2, because they're equal lengths, 2, 2. It's equal to root 5 over 2 times x. Okay, so now area of b equals 1/2 base times height equals, we have the base, 1/2 times root 5 over 2, root 5 over times x times the height. What's the height? The height is this 4, that 4 right there. Okay. The way that we're gonna get that is with Pythagoras' theorem again. So we have A, we're gonna solve for B, and we need C. So c squared minus a squared equals b squared. We need the hypotenuse of a. Hypotenuse of a squared equals 3 equals 3 squared. 2x minus 1 squared, 2x minus 1 squared plus x squared. And this comes out to, let's see, 4x squared minus 4x, right? Minus 2x, minus 4x plus 1 plus x squared. And this is equal to 4x squared plus x squared is 5x squared minus 4x plus 1 square root is 3. And then now we can do, remember 2 is equal to, let's do 2 squared actually. 2 squared is equal to 5/4 x squared plus 3 squared is equal to, no, plus 4 squared is equal to 3 squared. But we have 3, we don't have 4, so let's rearrange it. Can do, and we know what 3 squared is, because 3 is the square root of this, so 3 squared is 5x squared minus 4x plus 1. So we have 4 squared equals 3 squared minus 5/4 x squared is equal to 5x squared minus 4x plus 1 minus 5/4 x squared. And this comes out to be, let's see, 15 over 4x squared. So this is 4 over 4, that's 20 over 4, minus 5 over 4 is 15 over 4. 15 over 4 x squared minus 4x plus 1 square root is equal to 4. Yeah. True. That's what 4 is equal to. But that doesn't help us at all with finding the area. Well, not at all, but it doesn't help us directly with finding the area of this region because this is not, I don't know the formula for the area of this kind of shape. But what I do know is that I can break this up into two triangles. There's a triangle right here. There's a triangle right here. See what I'm saying? And let's call this hypotenuse Q. These two triangles share the hypotenuse Q. Let's call that Q. Let me erase. Matter of fact, before I do that, let's solve for the area of B. So the area of B is 1/2. The base was 2. But remember, 2 is equal to √5 over 2x. And the height was 4. And we found that 4 was equal to 15 over 4x squared minus 4x plus 1 square root. So the area of B is equal to I'm gonna combine the √5 and the root 15 over 4x squared minus 4x plus 1. This will be x over 4 times, matter of fact, I'm not gonna combine it. But we're gonna leave it like this for now. And then I'm gonna solve for x. And then once we get x, we'll plug it in and it'll make this much simpler. So the way we're gonna get x, we gotta find x now. So we have all the components to solve for the area, but we actually need to figure out what x is. And the way we can do that is by splitting the area into two triangles. Pythagorean theorem, this is a right triangle here. 1 squared plus 2x squared, which is 4x squared, equals q squared. That's the hypotenuse. But remember, it shares the hypotenuse with this triangle, which is equal to 2 squared, and 2 was √5 over 2x squared, √5 over 2x. So if you square that, you get 5 over 4x squared plus 4 squared, and 4 is this mess. So if we square it, we get 15 over 4x squared minus 4x plus 1. So we have q is equal to both of these things, which means they're equal to each other. We can cancel some terms. This 1 is going to cancel with this 1. 4x squared. We got 4x squared equals 5 over 4x squared plus 15 over 4x squared minus 4x. This is 20 over 4x squared, which is equal to 5x squared minus 4x equals 4x squared. Let me bring this 4x to the other side, subtract 4 here, x squared equals 4x. And now we're left with two possibilities, either x equals 0 or it equals 4. So both of these solutions you can plug in and they make this equation true, but if x is 0, then this problem's not interesting at all, so I'm going to say that x is equal to 4. X equals 4. Now if x equals 4, we're going to plug 4 in for all of this. AB is now 2 times 2 is 4 in the denominator times 4 in the numerator makes 1. This is √5 times 4 squared is 16, divided by 4 is 4, 15 over 4, minus 4 times 4 is 16, 15 minus 16. 15 over 4 times 4 squared is 16, divided by 4 is 4. 15 times 4 is 60, minus 16 plus 1 minus 15. This is root 5 times root 60 minus 15 is 45. But 45 is 15 times 3, root 5. 15 is 5 times 3, root 5 times 3 times 3. This is 5, this is 3. Together they make 15. The area of B is 15 square units. Now let's plug 4 in for everything up here. So the total area of the shaded region is 4 times 4 squared minus 4 squared plus 4 over 2 minus 4 squared minus 15. Let's see. 4 squared is 16 times 4 is 64 minus 16 plus 2 minus 16 minus 15. 64 minus 16 is 38. No, 48. 48 plus 2 is 50. Minus 16 is 34. Minus 15 is 19. Area of the shaded region is 19 units squared. So this was a cool math problem that could be solved. Granted, like, it was tricky. We had to employ a lot of Pythagoras' theorem and also the area of a triangle several times. And there was a clever trick we had to do with splitting the shaded region up into 2 different triangles. It was tricky, but we really only needed 2 equations, some cleverness, and we could solve it using elementary geometry. But I thought it was a cool problem. Thank you for watching.